So how to unsplitting Gerrit, so that's what I'll be talking about today. How to ensure multi-site cluster healthiness at scale. So today I'm going to be talking about, we've got a large cluster, a lot of nodes, a lot of machines. We're all replicating data between one node and the other. How do we know that those nodes are actually in sync and like one node is not left behind or irremediably broken? Spoiler alert, unsplitting Gerrit is really, really difficult. So let's see how we get to a state where it's not split to begin with. All right, so first of all, why replicate? So why would I want to have like a big cluster? Why would I want to bother with orchestrating data between different nodes and all of that? So obviously it gives you no single point of failure. That's a pretty big advantage. If one of your nodes goes down, you can keep serving data from any of the other nodes. Customer doesn't even, sorry, when I mean customer, I mean the user doesn't even know that your server's gone down. You just keep operating, and then behind the scenes, we're doing all the hard work to get that node back up and running. You can distribute loads across machines, so that allows you to have smaller machines. It enables horizontal scaling. Obviously, in a Gerrit installation, vertical scaling is really difficult because like you have to have some downtime at some point to increase the size of the machine. So yeah, it just enables you to do a lot more maintenance. It also enables blue-green deployments. You can start upgrading Gerrit nodes with like, you upgrade one at a time, ensure everything is correct, and then you can move forward. So it just enables a lot of fancy stuff that allows us to maintain our Gerrit installation a lot more efficiently. And finally, this is one that I love, geo-distribution of clusters. Like, I love that people actually do this. So if you've got like a team in China and a team in Europe or something, and you want to have like really good performances on like both ends of the world, you can have a cluster more like closely located to one geographic region and another cluster in a different geographic region, and everybody's happy and working together. If one goes down, someone is going to have slightly lower latencies, not the end of the world. They can't keep working like nothing is happening. So what to replicate? It's not as easy as just replicate my Git data and everybody goes off and dandy and everything is great. No, there's actually a lot. It's not all done by one single plugin because there's a lot of work going on and we like our microservices. So the indexes and the cache evictions, that's replicated by the multi-site plugin. We're not going to focus on that too much, but you're going to see it pop up here and there. The web session broker, so what does this do? So say that you're logged in on one machine, then that machine goes down and you just get redirected to the next machine. You don't want to have to relog in again, so we know which user is logged in, and there you go. One node goes down, completely seamless experience for the user. And finally, today's focus, the Git data itself, of course. we can't really function if we're not replicating that one. So we've got two main ways of doing this. I think the historical one, when I still wasn't part of this world, is the push replication. So what we're doing here, just because one thing that I really like actually when I came into this world is that this is not to do with the architecture of your cluster, but it's Git push and Git pull. So we're replicating the data over the Git protocol itself, right? Simply because of how a push works, you're sending all the data all the time. There's not much you can do about there. This means that there's a heavier network consumption because obviously you're sending more data than you need to send, and so you're putting more strain on the network. And most importantly, this goes completely behind Gerrit's back. Like you're literally pushing to the repo or to the file system on the other node, and Gerrit literally doesn't know that this is happening. Like the Gerrit server could not be there. In fact, we have some clients that have replica nodes that don't even run Gerrit. Or poor replication, if someone has been following GerritForge for a while would know that that is probably our preferred way of doing things. So we've got, because of how pool works at this point, you're only sending the data that is required. So there's a phase where we exchange, like we find a common base between both nodes, and then we pull that data, and so only what's needed. It gives us much faster replication times. We'll see about that in a second. And Gerrit is fully aware of what's happening. This is fully going through Gerrit, so yeah, everyone's nice and happy. There's a lot of complications, as we'll see today. There's a lot of moving parts. There's a lot going on. So why bother, right? Why change from push to pull? This is the kind of improvements that we're looking to get here. So we've gone from having some pushes that were taking over like 15, 17 minutes to the order of a few hundred microseconds. So, sorry, milliseconds. So yeah, like I don't think this can get like much quicker than that. How does it all work? How does it all fit together? This is a healthy pull replication workflow. So what we've got here is we've got our client that is writing to one instance, and then we've got client 2 that is writing to instance 2. Everybody starting from the same state. You've got my user, myself, for example. I'm creating a commit, I push it, instance 1 receives it, replicates it over to the instance 2. Everything's going well. Suddenly, after the replication, instance 1 goes down. I don't know, Ponch decided he didn't like me and just killed the node. Client 2 arrives, does a commit, pushes it, realizes that it's missing a commit, realizing that it's missing an intermediate commit there, so it has to pull it. Now our Git history is nice and linear. We push it again. Node 2 is nice and happy. Everything is working fine. In the meantime, instance 1 has restarted, and then instance 2 can replicate again to instance 1. Everything is in sync. Everything is good. Yeah, so client 2 doesn't have it. So when it goes to push, right, the server will say, hold on, you don't have the right parent. The parent of your commit is behind, so you don't have the latest version of that branch. So you need to pull the latest version of that branch, reapply your commit on top, and then you're good. From the server. So instance 2 does have it. It's the client that doesn't have it in this scenario, all right? So instance 2 has it. Everything is like aligned here, all right? But that is a good question because it leads us on to the next problem. Problems happen, all right? So again, same scenario. Client 1 pushes, but instance 1 comes down before it can replicate to instance 2. And now exactly what you're saying happens because client 2 goes to push to instance 2. Instance 2 doesn't know that it has missed a commit, so it thinks that the parent is correct, accepts the write, boom, that is it. Now we've got two branches, the same branch diverging on the two different nodes, and there's no other way of recovering this but someone logging in, figuring out what's happening, and manually sorting it. When it's one commit, not the end of the world. If this goes on for a while, this potentially is not remediable. Like this could potentially be catastrophic, all right? So yeah, instance status diverged, and yeah, we can move on from here. So just to be sure about this, you've got your commits on node 1, A, B, and C. You've got your commits on node 2, A, B, and D. Node 1 pulls from node 2. It's not the same parent. You're screwed, all right? So this is what we define as a split brain. Now, it's really important to know what a split brain is and what isn't a split brain. So a split brain is exactly this scenario. You have two nodes with diverging history. It doesn't affect all repos. So it could be that like one repo is out of sync. Doesn't mean that you can't work on all the other repos or even the other refs. And it requires human intervention, right? This is the only scenario of a split brain. All right, this is the split brain. What isn't a split brain? There's a bunch of other things that can go wrong. That's not a split brain. If a node history is further ahead than another node, that's not a split brain. You can just pull that and you're back in sync, right? If a ref is missing on one node, I don't know, for some reason the ref didn't get replicated, you're not in a split brain. You need to pull it, but that keeps working. Like it's all good. You haven't diverged. You need to pull it, right? And again, this might be one the inverse of the other, but it does happen that, for example, you go and delete a tag, and that tag deletion doesn't get propagated. You're not in a split brain scenario. You just have to delete the tag on the other nodes, but like nothing really happens, all right? So it's really important to understand what a split brain is and isn't. So how do we prevent this from happening? Introduce the RefDB coordinator, all right? So same scenario, client 1 pushes its commit. Instance 1, before acknowledging that it has received that commit, it will go and update the RefDB coordinator. So we'll check with the RefDB that it has the latest version, so the parent is correct, updates RefDB with the new commit, and then signals back to instance 1 that, hey, I've got the latest version, feel free to tell the client that it's all up to date. Now, when instance 2 goes to push, when client 2 goes to push, instance 2 checks with the RefDB coordinator if it has the right parent. The RefDB will say, no, this has been changed. Tell your client to pull. The client pushes and then is able to, so same scenario there. So once the client has pushed, now the scenario is all in line and you can push again. This is even possible while instance 1 has crashed. So this check doesn't require instance 1 anymore. You've got your RefDB coordinator there doing the job for you. Obviously, RefDB coordinator has to stay up. If that goes down, we're back at the starting place, all right? But you can use technologies that are highly available, like Zookeeper, AWS, DynamoDB, so it just allows you to use different technologies, right? Yeah, that is in short the work of the global RefDB. So how does it work now? Some of you might be familiar, and maybe not. So it stores only the mutable refs. So what's a mutable ref? So when you're creating a change on your server, when you're doing when you refs for master, on the server you're actually creating at least 2 refs. You've got your meta ref, which is the one that tracks the state of your branch, of your change. And then you've got the patch set. Now, patch sets are immutable. Once a patch set has been created, that is it, doesn't change. But the meta change, the meta ref, evolves with the history of your ref, right, of your change. So if you push a new patch set, the patch set 1 stays exactly the same. Patch set 2 is created, and the meta ref is updated to signal that there's something has happened on that change. All right, and we only store that in global RefDB. There's no point in storing patch sets because they don't change. Like, they're always going to be the same. So what's changing there, and what's like giving us what's giving us the true state of our change is the meta ref. Then decides, as we've seen, what's considered up to date and what isn't. Now I'm going to dive a little bit into how this all fits together in a second. I've got our client, pushes to node 1, the multi-site receives it, checks with the global RefDB as we've been saying it, then tells pull replication that we're all good. Pull replication uses the apply object, which we're not going to dive into too deep here. I just wanted to give you guys a full overview of the whole system. Pull replication uses an apply object, which is a very efficient way of like sending small payloads to the second node. So if the payload is small enough, we don't even do a pull. We just send it to the other node. The other node confirms that it's up to date, checking with global RefDB, and accepts the apply object. If for some reason the apply object fails, so for example, global RefDB told me that you're not up to date, you need to do a fetch here because your parent is not the same, then we do an HTTP fetch. So that tells node 2 to actually, bother to fetch this because I can't apply your change directly. But as we've seen before, if something happens and a node goes down, how does the node, when it comes back up, know that it needs to catch up the events that it's missed, right? So say a node goes down for an hour and like loads of stuff has happened. When it comes back up, how does it know everything that's happened? The events are stored on this events broker, usually Kafka, but whatever technology you want to use. And then events broker on the other side, so Gerrit is able to like read those events, pass them on to pull replication. Pull replication can go off and fetch them from the other nodes, and so it automatically comes back in sync when it starts back up. So I've got 2 nodes here. So if we do a PWD, you see I've got instance 1 and instance 2. I have got, where am I here? If we look at the config of Git, I'm pushing to different nodes. So if you see here, this repo above is pushing to node 1, so the port is different, and this is pushing to node 2. All right? So when I'm pushing to 2 separate nodes. While here I'm on the server, so if I do a git show ref, now I've been using this a little bit, but you'll see how, so if I go into the repo, and I do a git show ref, you can see how I've got my meta ref, and I've got 2 patch sets, all right? This is currently all in sync, because you can see the SHA-1 is the same, okay? One that I push to the first node, and here I go to the one that pushes to the second node. Let's see what I've checked out. Yep, so you can see here I've got checked out the same commit on both nodes, so the parent is the same. So what I'm going to try to do now is I'm going to try and do a change on both nodes, on both clients, and push it to 2 separate nodes at the same time. And what I would expect is for one of them to fail, all right? Because they're starting from the same parent, so they can't really be written at the same time. Otherwise, the 2 nodes would be out of sync at that point. So if I touch a file, this has already been created. So if I vim it, my second line, and I add it. Right, so now we should see one of the 2 failing. There you go. So this one went straight. This one is taking some time. If we go on the server and I'll do a git show ref now, you can see there's 3 patch sets, and this has actually been replicated. So the commit from the second node has not been processed, so the nodes are still in sync. Nothing too bad has happened here. All right, cool. So as we can see though, the server has not been corrupted. They're both still in line. One has gone through, one is hanging. I'm not 100% sure why it's hanging. I'm gonna leave it there running for a while. It'll probably eventually time out and everything will be fine, all right? So how do we monitor this, right? So you guys saw how I was trying to debug this. I was going into the server. I was like doing my git show ref. It's okay if I've got like a small setup like this, but really if I'm on a production system, this is not really gonna scale, right? The problem here is eventual consistency. So we're not expecting everything to be in sync all of the time. There's going to be periods of time where the nodes are out of sync, right? So how do we know that a node is out of sync temporarily, but that's fine for now, because something is happening in the background that is making everything go well, all right? So we've got a few things. There's no real silver bullet here. There's not really one thing that's going to tell you everything is fine. There's a few things. We play them all together and get a good result at the end, as we'll see. So we've got 3 main players. We've got replication lag, which is an interesting metric. It's based off the ref multi-site version that I think Ponch was showing a second ago. So what this does is, as someone was explaining, ref multi-site version is the last time that the repo got updated. All right, so every update to the repo signals, updates the ref multi-site version with the latest timestamp of when that was updated. So what we do here is we calculate the difference from the timestamp that's currently written there, the current timestamp, and yeah, that is the lag, okay? It doesn't really matter how tall the lag is here. The important thing is that it's small spikes, okay? So say that a repo is not updated for 3 days because nobody's pushing to it. Whenever we update it next, we will have a replication lag of the height of it will signal 3 days. But because it's like a very short spike, it means it went back in sync and everything is running all right, okay? So it doesn't really tell you if something it doesn't really tell you that everything is all right, but it tells you that something is definitely broken. So if you have a high replication lag that's not coming down, definitely something is screwed on that repo, all right? But if there's no replication lag, there could still be problems because this is not ref specific, all right? So it could be that I failed to update a ref, but then the next ref went fine and the replication lag goes back to 0, all right? But that previous ref that I failed to update, nobody like that's still behind, okay? So we still need to update that. So how do we sort that out? Local checks. So on each node, we expose a number of metrics. This is not out of the box. This is 2 different plugins. So this is called the local refdb plugin. Exposes 2 metrics that are commands that you need to call. So you've got the number of refs, which I kind of like because it's just a count of the number of refs on each node, which is good because you can follow like the historical evolution of it. So say that you can see where you've got periods, for example, where one of the nodes is lagging behind by a lot. Then you can see that over time. You can see if that improves with like correction actions that you take. Anyway, it's something that you can see the history and the evolution of it. It can be calculated under heavy load. It's not an expensive operation. We've got really busy repos that we just run. It's all good. And again, it's eventually consistent. So it's absolutely fine for this to be a bit different at time. Eventually, it should always reconvene, but unless it starts diverging and not recovering, like it's okay for this to not always be zero. So as we saw earlier with the mutable refs though, you've got some of SHA-1. So you can have different SHA-1s, but the same amount of refs. So you can have a situation, which we'll see now, where if one node is down and you've created a new, you've pushed the master, you've still got one master branch, all right? But the number of refs, so the number of refs is the same, but the SHA-1 of your master is going to be different. So the number of your refs is still one, but the sum of the SHA-1s is going to be different, okay? It's Boolean, obviously, so we compute this between nodes. So we expose this to multiple nodes, and then we see that it matches, all right? If it matches, it matches. If it doesn't match, it doesn't match. There's no other meaning to it, obviously, being a SHA-1. It's a heavier operation. We don't really recommend running this all the time. It's not the end of the world, but I wouldn't run this every minute or every 2 minutes. And it should be calculated during a read-only window, because this being a Boolean, it doesn't make sense if it doesn't match. Like, it doesn't give you any extra information. You just think that something is broken when it's probably just a replication going on in the background. So you want to be sure that you've got, like, the repo is inactive when you're operating on this one, all right? So yeah, next question, how does this scale, all right? So if I've got 2 nodes, you do node 1 versus node 2, that's fine. But if I've got 3, 4, 500 nodes, how do we scale this across the whole thing? Well, the question is, you don't really need to do the factorial, so you can check only node 1 versus node 2, node 1 versus node 3, and you just check that. I'm picking node 1, but you can pick whichever node and just make sure that one of the nodes is in sync with all the others. If one is not in sync, so in this scenario, everything is fine, everything is green. In this scenario, node 3 is out of sync, so we just say that the SHA-1 is different, something is wrong, go and investigate it. But this gives you a good visual clue that something is off on one of the nodes, go and figure it out. All right, so you can see, okay, you can see here, this took a little bit of time for some reason, but it did fail eventually, okay, few. So what I'm gonna do now is I'm gonna bring the repos back in sync. So I'm gonna check out my latest change. So I've got patch set 4 now, so I'm gonna check this out on here. Then we're gonna go on the server. If I do a git show ref now of these, it should be in sync. Yep, I've got 4 nodes, I've got 4 nodes. So if I run my command, so obviously I wanna run that. It doesn't really matter. I don't need to use 2 separate windows for this, sorry. But anyway, now I've got it. So, see, the number of ref, both have 8 refs, and we can see this on Prometheus, refdb. There we go. Split brain scenario is the one I'm using now. I just changed the number, the name of my project. So if you can see here, the number of refs is the same on both nodes, right? So, yeah. So yeah, that's 8. Both nodes are in sync on this, so it's all good. Now, if I run the command for the SHA-1 of all the refs, you'll see that it should also be in sync. How am I going to graph a SHA-1? There's no way of graphing a SHA-1, right? Can't do this. So what we do internally is we convert this to a number. And because this is Boolean, if they're the same SHA-1, it will give us the same number. If they're not the same SHA-1, it'll give us different numbers. Again, if they're close, it doesn't mean anything. It's either an exact match or it's not. So if we go here, we execute this, you can see that, this is the SHA-1 of the all refs. It generated whatever number is this, it doesn't matter, but you only see one line, which means they're in sync, all right? Cool, so what I'm gonna do now is I'm gonna kill one node, I'm gonna stop it. So I'm taking down node 1. I'm gonna go ahead and I'm gonna do a commit on node 2. My third third line. All right, so we're going to push this. And this is going to be fine because node 2 is fine. Node 2 is up and running, so this all goes well. We don't know that this is missing on node 1 because node 1 is not being used at the minute. If I bring node 1 back up and I rerun the same commands, you will see that they're different. Now, this is because I have disabled the feature of the events broker that I talked about earlier. So the node will not catch up when it restarts. I did that because it's just handy for the demo. So if I start up the node here, and then we go back on the server, you can see that, where am I here? Here I am in the client still. So if I go here and I do a git show ref of this, you can see that these are now going to be different. So if you look at the meta, this is node 1, this is behind, and this is node 2, this is ahead. All right? So it's also got a different number of refs in this instance because I've pushed a new patch set. But had I pushed directly to master, like Master Punch was telling me, you would only have the same amount of refs, but with a different SHA-1. All right? So now if I rerun my commands here, so this has 9 refs, this has 8 refs still, all right, because it hasn't received the patch set. So that in the graph I could show you, but I mean, you can see how this is going to be different. And also, if we rerun, this is going to give us something, and this is going to give us something else. Yeah, they are different. So those are going to go back to a different number, and we are screwed. All right, so this, as you can see here, is just different. And then this has changed as well. So here you've got 2 lines. I suspect here, still wait, there you go. Here you've got, this one hasn't changed from before. Now this one has changed, completely different number. They don't match, doesn't mean anything. Global RefDB checks. So this is still a bit iffy. I've got these 2 metrics. They're different. Where do I go from here? How do I figure out as a user what refs are out of sync and potentially even automate all of this, all right? So this is a different plugin called Global RefDB Checks. What this does is it checks all of your local mutable refs against the global RefDB. So it will list, literally does a git show ref, picks all the meta refs, does a call to global RefDB, and checks that we've got the latest SHA-1, all right? Well, latest according to global RefDB, of course. It's a pretty expensive operation, especially the bigger the repo, this is gonna get intense. It doesn't expose any metrics, just because at the moment it doesn't. It can be changed to do, but at the moment it doesn't. One thing you want to be careful when running this is not rate limit yourself. So if you're using something like AWS and you've got like a provision capacity, it's very easy that this will go over it very quickly. So, and that takes the whole of production down. So you don't want to be doing that. On one node, you can see it will tell you ref multi-site version is outdated and ref changes meta is outdated. If I run it on this node, it will tell us that everything is okay. All right, so this is completely up to date. The other one is outdated. So yeah, now we know this. Can we resolve automatically? Well, at the end of the day, guys, it's not that difficult. We've got this output. We've got ref changes. We know that we need to fetch this. We know where we are. We know what we need to fetch. So yes, the answer is we can resolve this automatically. We do this for some of our customers. We're looking at some point to maybe provide an open source solution, but we're not quite there yet. Still need to fix a few things. But yeah, it is doable to fix nodes in an automatic way. How do I know that I am missing a patch set? So I know the global RefDB tells me that my meta ref is out of sync, right? But it doesn't mention anything about missing patch sets, right? So if I'm only checking my local meta refs against the global RefDB, I will have a list of all my meta refs out of sync. But I've got no clue if the patches have been replicated or not. So there's a really handy endpoint in Gerrit called the check endpoint, where you can call for each node, and it will tell you if that node is, I'm not sure what the right word is, but intact on that node. So it will tell you if it has all the elements it needs to reconstruct that change on that node. So if it's missing patch sets for that change on that node, it will list them. So you can then use that list of refs to also fetch those. To finish for today, I want to talk about restarting a node. So in this world, restarting a node is usually all right, but we have seen, and Srini knows it well, we have seen issues where for some reason, pull replication doesn't seem to unload correctly. So we recommend to unload your events broker plugin, so events Kafka, events whatever, first. Unload the pull replication next. So this will like completely stop ingestion of events. And then you gracefully restart Gerrit. And this will give time for like the plugins to finish computing their stuff, and everything is good. Obviously, don't leave too few nodes to save incoming traffic. You don't want to kill yourself. But yeah, that is pretty much it so far. Any questions? But at the minute, I don't think that would be a supported use case. Like global RefDB would need to know that that has been updated. Not so much Gerrit itself, but global RefDB would need to be updated with the latest versions. But then you mendeling with global RefDB yourself. Yeah, we would need to look into it. Yeah, for sure. So the local RefDB, we're actually experimenting at the minute, but we're down to like one every like 3 minutes or 5 minutes, I think it is. It doesn't really, like that is a really quick operation. I think we have an absolutely massive repo and it takes like milliseconds to compute. So I'm not really too concerned. It's just, you don't want to be like constantly adding load to the machine just for the sake of it. But yeah, every 5 minutes we're just checking. I don't love it. I would prefer to have this like real time, but there's also like, there's pros and cons to that. While the global RefDB, sorry, the sum of all the SHA-1s, the repo is incredibly busy, and there's literally not 2 minutes in a day that some robot or some user is not updating it. We have a backup window like at midnight where we do our backups, and it's a 5-minute window where we already received plenty of failures. But anyway, we run it then. So we've got a read-only window. We just typed into that and run at that point. Yeah. Ideally, we would look at doing that at some point. Yeah, for sure. So I'm going to answer myself a question. What happens if we replicate the meta ref, fine, but we don't replicate the patch set for whatever reason? So this obviously you guys couldn't know this, but there is the apply object. There is a limit at which like we then decide to go through the fetch, and this ties with what Martin was talking about earlier. But it has happened that there are events that go through apply, because the update of the meta ref is usually very small. It always goes through apply object. So the ref on the other nodes is updated. The meta ref is updated, but maybe the patch set is massive and we can't just send it over the network. So we do a fetch, and maybe then the fetch fails for whatever reason. And now we're in a scenario where the meta ref has been updated. So we think that everything is fine, but we're missing the patch set. How do we fix that? There's not really like an easy answer. What we end up doing is we literally have like an Ansible script but that is when the number of ref metric comes in handy, because at that point, the SHA-1 and the number of ref will be different. So when you detect that, what we do is we do a git show ref on every node, write it to a file, download the file, do a diff, and we figure out which refs exactly we are missing from the nodes, and then decide what course of action to take. Usually we need to fetch it, but yeah, we need to look at it and see a bit what happened, and then dive deep into why that happened and fix it. But what Martin did, fix this, because now we can send patch sets, we can send events together. So in that scenario, we would probably like send both to the events broker, or yeah, now we can tie them together. So when that comes out, that shouldn't be a problem anymore.
situation
yeah.
and all the instruments to fix
Yeah.
the situation automatically.
Yeah, I think this can all be automated. We're not at the point where we've automated it, but it's all automatable. Yes, like definitely. Yeah, it tells you. Yeah, it tells you that your node is behind. So yeah.
Which one is the latest?
I believe this is the one that's on your node, and this is the one that is in Global FDB. So on this node, it will tell you, yes, you're out of sync. This is what you've got, and this is what you should have. We wanted to use today to announce that we'll start hosting some monthly meetups, Gerrit meetups around the Bay. Probably here, the first one, hasn't been decided yet. But what we'll be looking to do is, yeah, host monthly meetups, probably talk, host a few short talks, probably like 15, 20 minutes, maybe have a few. We'll have some food. Yolanda will be prepping it all.
I'm reaching out as well. Of course, absolutely.
And then, yeah, so we will have, yeah, this is a thing that will be happening, and we plan to do that. And the next one is hopefully going to be, well, first one, however you want to see it, hopefully going to be on the 16th of November. And then maybe not one in December, and then pick it up back up in the next year, and yeah, have that as an occurrence. If anybody of you guys wants to host it, give us a shout. But yeah, that's something that we'll be doing. Cool.